Welcome to Snap Cloud, a backend for spectacles powered by Supabase. I'm presenting today in Teleprompter, which we released in Lens Explorer for LensFest 2025. Teleprompter lets me easily read my notes. It also integrates a lot of cool Snap Cloud features, like authorizing into my Google account and controlling my slides with our Chrome extension through our Supabase Edge function and Supabase Real-Time. Building compelling experiences for AR glasses often demands more than what runs on device. Multiplayer games need shared state. Multi-level games require persistent progress. Fitness challenge lenses need shared state and leaderboards. Personalization requires knowledge of user preferences. And until now, spectacles developers who wanted back-end capabilities like this had to provision their own infrastructure, spinning up servers, managing databases, handling authentication. I mean, it's a real headache, all before writing a single line of lens logic. SnapCloud changes that. It's an integrated backend platform powered by Supabase that gives spectacles developers production-grade backend services directly within Lens Studio. Databases, file storage, server-side logic, and real-time connectivity are all available with minimum setup. How many people here have used SnapCloud so far? Oh, wow. I need to skip ahead. Are you bored already? All right, okay, let's go. I'm going to move it along. In this talk, we're going to walk through why we partnered with Supabase, how the architecture works under the hood, and what the developer experience looks like. When adding backend capabilities to the Spectacles developer platform, we determined that the operational complexity of hosting an open source stack in-house would pull our focus from building a great developer experience. Instead, we chose a deep engineering partnership with Supabase to provide the required broad set of primitives like relational databases, object storage, and real-time publish subscribe in a way that is approachable for AR developers. And I take it as validating that so many of you have already used SnapCloud. That's kind of amazing. I feel like I saw 70% of the hands go up. Supabase stood out for us for several reasons. The first is that it is Postgres native. Okay, do you know what how many people know what Postgres means? Oh my gosh, I'm sorry. I underestimated you, I'm sorry. Well, okay, so I didn't want to leave anyone out because we stand so much to gain from anybody who hasn't used SnapCloud, okay? So if you haven't used it, I hope that this talk convinces you that this is for you. So I'm going to talk a little bit about Postgres. Maybe you already know this. The term originates from terminology related to land rights originally. It kind of makes sense, right? Ingress is for people's entering a new land, and egress is for people's exiting the land. This is land rights. In 1974, one of the first relational databases was made at UC Berkeley, and it was called Ingress. What it was known for was its hybrid transactional and analytical capabilities. And then later, a team member was like, I'm going to do that better. And he made another project called Post-Ingress. That became Postgres, basically. In the 1990s, the database query language SQL had become standardized and was added to Postgres by default. So Postgres usually means Postgres SQL, but I think people mostly say Postgres. What's meaningful to me here is that in parallel with the development of the internet, what we are seeing is an architectural trend away from layers of custom backend code looping over data towards the databases themselves being the smart, safe, stateful core of the experience. It's kind of interesting, right? With Supabase, every project gets a full PostgreSQL instance. There's no proprietary language to learn. The instance comes with row-level security, which means each database request is checked against policies. So a user or role can only access the row that they're allowed to. You get a lot of extensions, which are add-ons that unlock extra capabilities. For example, with Vector, you can store vectors for products, text, images, other data. So vectors, you can track the similarity between these things, then run vector similarity to find related items. You don't need a separate vector stack just to prototype smart experiences. This is especially useful for AI workflows, where you store embeddings for retrieval augmented generation, or RAG, which is a way to make AI answer using your own data. So if you think about the database as the core, and then you have this vector extension, and then you have AI being like, running updates as the data is changing, maybe reactive UI in your experience, you can start to see how this experience is starting to personalize to your user without you having to do anything. And so you get a full SQL surface area, not just the basic CRUD. Who knows what CRUD means? I'm going to stop testing you. I'm sorry. Okay, CRUD means create, read, update, and delete, typically mapped to SQL as insert, select, update, and delete. But full SQL, what we mean by full SQL, is you get the complete power of CRUD, basically, but also joins, transactions, constraints, functions, and advanced analytics. So it's like a lot more functionality. With Supabase, you also get the open source foundations. You all are here because we see the value of developing with developers. That's the value of open source. It's built on proven components, Postgres, which turns your Postgres tables into APIs, GoTrue, which handles authentication and user sessions, Deno Edge functions for running server-side JavaScript or TypeScript, and S3 compatible storage for storing and serving files with standard object storage patterns. This means rich community resources, transparent internals. You can just go read the code and inspect the behavior, and well-tested primitives. Crucially, it also means that, let me just take a break, SnapCloud can contribute directly to the code base. So for example, when we developed and upstreamed a Snapchat OS provider into Supabase's open source GoTrue authentication service, we upstreamed a Snapchat OS provider, so the identity integration isn't just a bolt-on. It lives in the code base itself, like you can read it. Real-time is built in. Supabase Real-Time provides instant, bidirectional data sync out of the box. It's a natural fit for collaborative AR experiences where multiple Spectacles users interact with the same physical space. It bridges the gap when connected lenses system reaches its limits. Specifically, maybe some of you have done this, when developers need to execute server-side logic, or they need greater control over how data is processed and stored. With one click, Real-Time can also sync with a database to yield real-time updates to database changes. This is like a super cool feature. Like you literally click a button and then you suddenly get these messages every time your database updates, if that's what you want. And then lastly, developer ergonomics. The Supabase JS client library is widely adopted and well documented. By packaging Lens Studio compatible version of this with our library, we give developers access to a familiar API service without leaving their AR development environment. This is the story of one backend, multiple front ends. Supabase exposes your backend through REST APIs, real-time over WebSockets, and multiple client SDKs. And that lets one Postgres backend system support different clients, including spectacles, or mobile, or web, or what other crazy client you want to connect. So it's perfect for integrated experiences. With Teleprompter right now, the Lens Studio project, or Spectacles, and the Chrome extension connect to the same private Supabase real-time channels and exchange the same slide command payloads, even though they're using different client libraries. Global infrastructure. Supabase runs on AWS, Amazon Web Services, and supports project deployment across multiple global regions, including the United States, Europe, Asia Pacific. And each project's database, storage, and auth services are co-located within the chosen region. And edge functions are then distributed globally for low latency execution close to end users. This means that developers in any supported region can expect the same level of performance and reliability. And I just want to underscore the advantage of edge functions real quick. So historically, if you wanted back-end logic, you stood up fixed servers on Amazon Web Service, managed deployments, scaling, uptime, and paid for capacity even when traffic was low or nothing. You're basically renting server space. With edge functions, your logic runs on demand near the user, scales automatically, and you pay for usage instead of idle infrastructure. So for new businesses, that means lower upfront complexity, faster iteration, and a smaller team, even a team of one, just me, can ship production-grade features earlier. In our partnership with Supabase, SnapCloud maintains control over access policies, cost management, and data sovereignty, while Supabase handles the complexity of scaling Postgres, storage, edge compute, and real-time services. So the partnership allows for us to focus on what we do best, the tight integration with Snapchat's identity layer, Lens Studio's tool chain, and the unique requirements of an on-device AR, while Supabase provides the battle-tested infrastructure at scale. And I hope that the partnership allows you to do what you do best, which is making amazing experiences on spectacles. At its core, SnapCloud adds Supabase's full suite of backend capabilities to your lenses. When you create a SnapCloud project, an isolated Supabase project instance is provisioned for you, giving you Postgres SQL, a fully managed, scalable Postgres database with row-level security. Use it to persist game state, to track progress across sessions, or to share data between users. Storage, upload, organize, and serve files of any type, images, videos, 3D models, user-generated assets, but also most recently prefabs. Storage is fully integrated with your Postgres instance and governed by the same RLS policies. So access control is consistent across your entire backend. You also get the edge functions, run custom TypeScript or JavaScript logic server-side close to your users. Edge functions can be used for content generation, game logic, media processing, and more. Supabase is using an edge function in order to authenticate into our Google, well, first of all, we use AuthKit in order to authenticate into our Google API, our Google account, but then we take the ID token from that authentication, and we use that to automatically pair with our real-time channel so that our Chrome extension and Spectacles can automatically get onto the same channel. You can use real-time to synchronize state across multiple Spectacles in a shared session, push live updates from edge functions, or build an experience that benefits from instant bidirectional communication. By bidirectional, I mean like I can change the slides from my computer, I can do it with my hands as well. This is me debugging an early draft of teleprompter, and I really loved being able to see all of the messages flowing between the Chrome extension and my spectacles while I was debugging this. At that time, for me, all of the Snap Cloud stuff was like pretty fuzzy. And seeing these messages just gave me this like tactile sense of concreteness. It was really fun. It was a breakthrough moment for me. A key design goal in all of this was making Snap Cloud feel native to the Lens Studio workflow. We achieved this through two integration points, the Supabase plugin and the Supabase client asset. The Supabase plugin is installed from the Lens Studio asset library and surfaces directly in the window menu. It provides a management interface for your Snap Cloud projects, creating new projects, viewing existing ones, opening the Snap Cloud dashboard, and importing project credentials. The Supabase client asset bundles a Lens Studio compatible version of Supabase-JS. And once added to your project, you can initialize the client and begin making requests with just a few lines of code. Seamless authentication via OpenID Connect, or OIDC, is one of the trickiest parts of integrating a backend into any client platform. And on Spectacles, the constraints are uniquely demanding. Significant friction will be introduced when users wearing spectacles are required to tap through login screens or enter passwords. Authentication must happen invisibly the instant the lens launches. And we solved this by building an OIDC bridge between Snapchat's identity system and Supabase's GoTrue authentication service. Snap Cloud actually implements 3 complementary auth flows, each tailored to a different surface. The Snap Cloud, I know, overwhelming, I'm sorry. The Snap Cloud dashboard. So with the Snap Cloud dashboard, developers log in to cloud.snap.com using their Snapchat account via standard OAuth. This is the management surface for creating projects, configuring databases, and deploying edge functions. And then we have Lens Studio. When a developer opens the Supabase plugin in Lens Studio, they are seamlessly signed in to the Snap Cloud dashboard via single sign-on SSO. One click opens the dashboard in the browser, pre-authenticated, no separate login required. And then on Spectacles, on device, this is our third authentication flow. This is probably the most interesting flow. When a user launches a lens that uses Snap Cloud, the platform automatically establishes a secure session against the correct Supabase project without any user interaction. The on-device flow works through a layered process. When a lens with a Snap Cloud backend is published, the associated Supabase project identifiers are embedded directly into the lens metadata. This means that when the lens is launched on Spectacles, the platform already knows which backend to connect to. So no extra work, no extra network round trips are needed, reducing launch latency. The platform then issues a scoped OIDC identity token for the authenticated Snapchat user and the specific Supabase project. The lens exchanges this token for a Supabase session in a single API call. There is no OAuth redirect flow, no token management, and no login UI to build. Supabase verifies the token against Snapchat's OIDC provider, validates the project scope, and establishes a session. And from that point forward, all database queries, storage operations, and edge function invocations carry the user's authenticated identity, and RLS policies enforce access control accordingly. So security was by design, and it was a very important architectural decision. The token exchange is performed outside of Lens runtime. The Lens code, which runs JavaScript offered by third-party developers, never has direct access to the underlying Snapchat user tokens or the authenticated handshake. This exchange is handled by the operation system, and the Lens receives only the resulting session. This isolation boundary ensures that even if a Lens contains malicious code, it could not intercept or misuse the identity credentials. Security was a first-order design principle, not an afterthought. So for developers who prefer working outside the Lens Studio GUI, the Supabase commands line interface fully supports SnapCloud. Running Supabase with the profile snap flag directs all CLI operations, local database testing, schema migrations, deployment to your SnapCloud project. This gives you the same CLI workflow that Supabase developers already know, pointed at your Snap-hosted backend. We also support AI-assisted development through the Model Context Protocol, MCP. MCP enables tools like AI Coding Assistant to understand and interact with your SnapCloud project context so that you can iterate on backend-powered lenses locally before deploying. Being able to use MCP, and it's a little bit of a setup. It took me a few hours. But it's kind of amazing, and it closes the loop between local Lens development in Lens Studio and the remote backend services that power it. Every SnapCloud project comes with a full-featured web dashboard at cloud.snap.com. This is a customized deployment of the Supabase dashboard, not a fork, but a tailored instance with Snap-specific branding, terminology. The features that are enabled in this fork, in the dashboard, are only for Spectacles. So they all work with Spectacles, so you don't have to do that diff yourself. And at this point, I would like to just show you a little bit about the SnapCloud interface here for anybody who hasn't worked with it. This is what they're talking about, where you're limited to 2 projects. So here, if I'm creating a new project here, I'm going to call Bootcamp. Now I have my 2 projects, and that's it. When you import your credentials from the project, so right here, I have my SnapCloud demo credentials. Those were prior. These are the ones that I just created. And then you basically just drag this asset into your authentication script. And this is what all of your services are going to use to send that authentication data with whatever messages you're sending to the database. What's kind of neat here is you can just click right here in order to open your project in the dashboard. And you get immediate feedback about, well, almost immediate, feedback about what is going on with your project. And I just wanted to walk through really quickly here for anyone who's new, because again, we do stand a lot to gain from any developers who haven't explored these tools to try them and give us feedback so that we can make them better, especially for people who don't necessarily have experience with working with cloud-based experiences. So here is your table editor. We can create a new table here. I'm going to name it Bootcamp. And we can add columns down here. And I'll go ahead and create this. This is now one of the relational databases in my project. These other services are directly integrated with. What's kind of nice here is that you don't have to touch any code in order to add databases and amend them. So like in our minds, even if developers don't code, they could potentially use this service. That's a goal of ours. If you do code and you want to test your functions, you have your SQL editor here. So here I can just like run this, and basically this function is running directly against my database in order to give me feedback about like whether or not this is going to work. And then I'm switching to the database view. So this is like a schema visualizer of the many tables that I've created. And one pattern I'm pretty interested in is personalization, especially on spectacles, because we know, you could see some of my dropped pinches while I did this, which is getting a lot better with our next version of spectacles. But it's like input basically equals friction, right? So if you can have some kind of backend that is starting to build in personalized intelligence into your lens, you're basically cutting down friction for your user. Here's the authentication piece. So these are the UIDs of the users that have been sending information to this project. And I have my storage. Here's my test bucket, which is, these are basically like the Supabase examples that you'll find in the documentation in Snap Cloud Docs, which is the companion we talked about to the dashboard. So the docs here, like you can go to Supabase docs, but if you go to the cloud.snap.com docs, these are all the docs that are relevant to Spectacles development. So this is kind of what you want to be looking for troubleshooting and new features, and yeah, any way we can make your lives easier, it's going to be here. So if I run this project here, and we can see that it's signing in my user, and it's running all of these tests. Here's my database test. Here's my edge function test. Here's my storage test, where I'm getting back this little picture and a 3D model. We're also supporting prefabs now, so that should make life easier, I hope. And then the real-time test. And then just to touch on the real-time test real quick. So here I can see the events that are occurring in real time. I can also broadcast a message. So me, right here in this dashboard, I'm like another client. And I can broadcast a message like hello world, which is going to be received on this side. These are just like debugging tools that were really meaningful to me. And then here's our edge functions. This is a very simple one, which is just making a sum of two numbers. And you can view the code here. And we can also look at the policies attached to this. And just on that note, I wanted to point you to the advisor section here, which can give you recommendations for how to make your project more secure. So here, for example, it says I have a critical problem with RLS disabled in public. And here I can ask my assistant for advice about how to fix that problem. And it can guide me step by step to making a secure, more secure project. This is the teleprompter sample project that I just wanted to share for you guys. So this is what teleprompter looks like from my perspective. So what this does is it models that hybrid authentication flow that we talked about with the ID token, and teleprompter is just implementing it manually before that feature is released with the traditional auth kit. And then there's some more things that I think is pretty cool about this project. So here we're going through like the usage of the auth kit, And then it also showcases how to utilize Google API, how to access Google API. And for us to get access with this project, we had to apply to Google as a limited input device. That was like crucial. Like we had to make like 4 applications, honestly, to get access to your Google Drive here, because oftentimes Google is hiding that kind of access between web portal, a web interface. And they kept on being like, use the web interface. And we're like, I can't. And then, yeah, we're using this double pinch guide, which in my opinion is like the most secure input that we have right now that has like very, very few false positives, few false negatives. I had a lot of slides today, but it's like, it works pretty well for me. And this is calibrating off of the angle of the cameras pointing downwards on the device to identify the pinch plane that is acceptable in order to eliminate false positives when you're doing stuff like on your computer or something. So if you are interested in trying to mess around or with or improve some kind of gesture like that, it might be helpful to you. And then, of course, we have the edge function for Supabase for you to use that hybrid auth flow. And then the Chrome extension, which you can, right now it is using the anon key, even though that is being deprecated. But I think the Chrome extension is pretty cool. Another thing that it teleprompter uses, which kind of relates to what George was talking about before, is spatial anchors. And I really love this aspect of the project. Like basically, when I just walk on stage, it like immediately localizes to the stage. It's so beautiful to like wherever I placed my slides prior. And we're also and this is another feature that we're just doing like manually in this project, but you could try it if you're interested, using the location API to get the user's GPS coordinates, and then use those GPS coordinates within the label of your spatial anchors area in order to automatically load the area for the area that the user is in. So teleprompter doesn't have any UI for the user to be like, this is my area, load it, it's named this, blah, blah, blah. Like the user doesn't actually know at all. Thank you so much for these requests, and I'll be sitting here trying to collect some more because that is my job today.